Hi, ma'am. Thank you so much. So it's it's my immense pleasure to have this session for our dear students. And I would like to thank you and Vinayak sir for organizing this session. So I could check that some students are joining, Abhiraj, Vinod, and all the students who are joining one by one. Beta, very good evening to all of you. I know it's already 8 o'clock and your time of dinner is nearby. But don't worry, I'll make sure that this session is an enjoyable one. Just hold on. I'll do one thing. I will share my screen with you and then we shall start. So the idea is like how physics is fun, right? How cool is physics? How physics can change our life. And I saw the title of the video is Physics in Our Daily Life. And I checked out like what kind of videos are there online. So common examples are everywhere, like how do we walk or how friction helps in moving the car forward. So such kind of examples are already there, ballpoint pen, etc. So I thought, why not have something uncommon? And that's what the agenda of this 1 hour session is, to have some really cool examples to enjoy physics, to understand what is the importance of physics in our daily life and for our future also. So I have lots of examples with me. We will do one thing based on how much time we have. We will discuss the examples. Abhiraj, Sindhu, Murlidharan, all the students who are joining, beta, you guys can use your chat box and ask me the questions anytime. If I will have your answer, I will have an answer to your doubt. I will definitely reply. Else, I will take time and reply it later on. So let's start. Let us start. So we are talking of physics, right? But let me ask you first, what is physics, or maybe what is science? Actually, physics is branch of science, right? So what is physics or what is science? Anyone? Anyone? If you don't want to type, you can answer directly. You can just speak out. I can hear you. You don't worry. So if you will Google the internet, you will see lots of definitions are there. They will say some definition will be like science is the embodiment of knowledge. It is the pursuit of verifying that knowledge and improving that knowledge. Very heavy definitions will come, and we will not be able to understand the definition, isn't it? So let me give you a very simple definition. Science is whenever you have question and you want to solve that question, that is science. If you have a question and you are trying to find answer to that question, that is science. Is the earth revolving around sun or sun revolving around earth? Why the sun rises in the east and sets in the west? How the sun is giving us heat? How the plants are making food? When I eat food, what happens to that food? How do we have a rainy season or a summer season, winter season? Like this. Any kind of question you have related to nature and you try to find answer to that question, that is science. So, matlab, this is the basic definition. No need of going to the internet and checking heavy definitions. And there are different branches of science. So, if you have a question related to human body, you will call it as biology. If you have a question related to some chemical reaction, you will call it as chemistry. And similarly, if you have questions related to motion, how things are moving, or what are the forces that are causing the motion, or maybe you have a question regarding light and its properties, you have a question regarding sound, electricity, magnetism, you have a question regarding the celestial bodies, you have questions regarding atoms, neutrons, protons, that is all physics. So physics is a branch of science which is going to answer these questions. Okay. So what I have in store for you. Actually, I'm sitting in an office which is in Cochin. So right now I'm in Cochin. And I'm feeling very lucky because the office that I'm sitting in, so it's hardly 100 meters from Cochin Shipyard Limited. That's the place where a lot of ships of Indian Navy are constructed. And INS Vikrant, this baby INS Vikrant, this aircraft carrier was born in Cochin Shipyard Limited. So hardly a few hundred meters from here, this massive aircraft carrier was constructed. So I thought ki Kerala is famous for shipbuilding. It is the capital of shipbuilding in India. It is the birthplace of INS Vikrant, and it's one of the homes to ISRO also. And yes, just a few days back, they have started water metro. They are using metro to transport people, and here people have a lot of craze for football. So Kerala is also like the capital of football in India. So Kerala and West Bengal. So I thought I will take my inspiration from Kerala, and I will take some examples related to Kerala. Some examples which are applicable over here. Actually, yesterday, while going back from office to my hotel, there was a park on the way and some people were playing football. So I was aware. Actually, I came to know that this session will happen. I came to know about it yesterday only. So I thought, why not take inspiration from here and discuss some examples? So do me a favor, watch this particular video. And if you like, I can keep the audio on. Watch this video, guys. Watch this video. So just for your reference, the two teams are Brazil and France. And the yellow uniform is Brazil. The actor is, sorry, not the actor, the player is Roberto Carlos. And he's taking a free kick, 35-meter long free kick. And you know what? So I hope you can see that in his way, there are some players who are standing. So they are obstructing his view so that he cannot hit the ball directly to the goal. This is what they are doing. But check what the magician is going to do. And by the way, in the world of football, this kick is like it is part of Hall of Fame. It's one of the most famous goals of all times of the football history. Check it out, guys. Check it out, and then we will see what is the physics involved over here, huh? So check out, please. I think you might say that the football is going along the straight line, but actually that's not the case, huh? Watch it again from a different angle. Did you see? The football had a swing. There was a swing in the football. And if you are playing football, you call it as banana kick. I have played football, so I was used to banana kick around the globe. So those kind of tricks we will do. Can anyone tell me how did this guy give a swing to the ball? How the guy give the swing to the ball? I mean, if you consider uh, like Newton's law of motion, someone might think that this is not possible. Let's check whether it is possible or not. Let's have a look whether this is possible or not. So what we have a goal. So this is the goal over here. Okay, goal post is here. And yes, in front of the goal post, there is a goalkeeper also. Let me put the goalkeeper over here. So this is the goalkeeper. And this is somewhere our hero, Roberto Carlos. So he's 35 meters away from the goal post. On the way of the ball, some people from the other team, they are standing. Some players from the other team, they are standing. They are obstructing the path of football. So definitely, Carlos cannot hit a direct kick. But what he does, he hits the ball towards the right. He hits the ball towards the right, and it appears as if the ball is going to will go off the bounce. But you know what happens? On between on the way, the ball takes a swing and goes into the goal post, right? So this is what we want to understand, that how this swing is happening. Now, first of all, let's have a look at the laws of motion. So, law of inertia. First law of motion says law of inertia. If there is no net force on the ball will maintain its velocity. The ball will keep on moving in same direction with same speed. This is law of inertia. And second law is net force is equal to mass into acceleration. If there is a force, there will be acceleration, net force. If there is no net force, there will be no acceleration. What is acceleration? Change in speed and direction, right? Now let's check. So when Roberto Carlos, when he hit the ball, actually he gave a direction to the ball and a velocity to the ball. So when he hit the ball, he gave a direction, a velocity to the ball. And yes, it's a kick in the air. So the ball is not grounded. So ball is moving up, the ball is moving up. And if you consider the forces on the force on the ball is the weight, which is downwards. The force on the ball is the weight, which is downwards. So force is there, that is the weight. And weight will be equal to mass into acceleration. Weight will bring an acceleration. Weight will change the velocity. So weight is downward. So change in velocity should be downwards. So as per the weight, the ball should go up and fall on the ground like this. As per the weight, the ball is going up, it should fall on the ground due to the weight. But why this swing is happening? Obviously, there is an additional force which is causing the swing. And that additional force is coming from the air. It's coming from pressure of the air. Let's see how. And believe me, this has lots of important applications, other important applications also. So what we have a car, okay? A car is there and the car is moving forward. So if the car is moving forward, basically I am standing here, I'm having a cup of tea, I'm looking at the moving car. As per me, the tree is at rest, the air is at rest, but the car is moving forward, correct? Now you consider yourself, you are sitting within the car. So as per you, it will appear to you as if the trees are approaching you, as if the tree is approaching you. It will appear to you that I am who is standing outside and having a cup of tea, I am approaching to you. And obviously, air is approaching to you. So situations are same, only the point of view is different. This is me, my name is Pranshu, this is me. So when you check my perspective, you will say the car is moving and other things are at rest. This is you. When they will check your perspective, they will think that other objects are approaching you. You will think that other objects are approaching you. So same situation, perspective is different. It is just like my boss will call me an employee, but my wife will call me a husband. So same person, but different perspectives. So let's take the second perspective. So in second perspective, what will happen? So this is your car and the air is approaching the car. Air is approaching the car. So air will flow around the car like this. So every object which is moving forward like a football, you can say every object which is moving forward like a football, air is moving around it. So the football which was moving forward, air was moving around it. So let me show the football. Okay, this is the football. So what we have football which is moving forward. Air is at rest. But we can consider that the football is at rest and air is moving around it. So some air will get deflected towards one side. Some air will get deflected towards the other side. Correct? Now, what Carlos did one thing. You take your pen and hit the pen in the middle. So pen will move forward. But now you do one thing. You take the pen and hit the pen on the side. Not only the pen will move forward, but the pen will rotate also. Pen will spin also. Same thing Carlos did. What Carlos did, he gave a swing to the ball. He hit the ball towards the right and then the ball swing towards the left. Correct? He hit the ball towards the right and the ball took a swing towards the left. This means when he hit the ball now, he did not hit the ball on the center, but he hit the ball somewhere towards the right of the center. This is the point where he hit the ball. Because he hit the ball is moving forward. And since he did not hit at center, he hit at right, the ball started spinning. So the ball which was moving forward, it was spinning also. That is very important. The ball was spinning also. And the ball was spinning about a vertical axis. Let's see what happens when the ball is spinning about a vertical axis. Check, it's very easy. So what we have a football. The football is moving horizontally. The football is moving horizontally and we are looking at the football from the top. So this is a mouse. I'm looking at the mouse from the top. Okay, I'm looking at it from the top. So the ball is moving horizontally. And you can also say air is approaching the ball. Air is approaching the ball. So this air will move around the ball. But the ball is spinning also. So ball is spinning in this direction. Now you know what will happen. So consider the right hand side of the ball. So in right hand side of the ball, the air is moving backwards, but the motion of surface of football is forwards. So definitely between them, there will be a sort of friction. This friction will slow down the moving air. So air on the right hand side will be slower. But if you consider the left hand side of the ball, so this is the left hand side of the ball, okay? If you consider the left hand side of the ball, the direction of motion of air and the direction of motion of surface of football, they are same. So football is promoting the motion of air. So on the left hand side, the air will become faster. Now you will say, sir, how physics is applicable over here? First of all, the friction came into picture, है ना? Spinning of the ball came into picture, Newton's law came into picture, and then friction came into picture. So definitely physics is involved over here. But physics is saying something else also. Physics is saying, as per Bernoulli's equation, so those students who are in 9th, 10th class, they will learn this equation in 11th class. What they will say, sir, the moving fluid has some pressure. And sir, the moving fluid has some speed also. So for a moving fluid, this sum remains constant. If the speed will decrease, then the pressure will increase. And if the speed will increase, the pressure will decrease. So this is something called as Bernoulli's principle. If you have learned it, very good. If you have not learned it, you will learn it in the next class, next classes. Now check, please check. Here the speed has decreased. So here the pressure will be high. So this will be a high pressure zone. This is going to be a high pressure zone. But on the other side, the air has become faster. So here the pressure will be low. So this will be a low pressure zone. On one side, the pressure is high. On the other side, the pressure is low. So pressure difference will create a force. Pressure difference will create a force. So check. The ball is moving like this. Force is like this. Ball is moving like this. Force is like this. Force is perpendicular to the ball. So check, check, check. So what is happening? So this ball which was moving forward, the ball which was moving forward, it was spinning about its axis. As a result, on one side of the ball, pressure was high. On the other side of the ball, pressure was low. And because of the pressure, there is an inward force. That inward force is going to swing the ball. So that's how we did it. And this particular phenomena, it's called Magnus effect. What it's called? It's called Magnus effect. So if you are giving such kind of swing to a football, to a baseball, or to a golf ball, so any such kind of swing is because of Magnus effect. It is because of Magnus effect. The spinning of moving ball creates a pressure difference. That pressure difference creates a force, and that force will swing the ball. It will deviate the ball from its original path. This is what Magnus effect is. Now, since you guys are Malayalis, I think like Rebecca and Vinod and Abhiraj and other guy also, all these people, most of you might be aware of what Magnus effect is because sometimes you guys play football. But can you tell me other applications of Magnus effect? What are the other applications of Magnus effect? And sir, why this is physics? Because whenever you study motion, whenever you study force, that is physics only. Here we are talking of motion of ball or force because of air pressure. That is physics only. So it's an example of physics. It's not example of something else. Anyone? 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 What is the other application of Magnus effect? Very good applications. Do one thing. So I hope you are able to see this paper. So you are able to see this paper. Okay. I think some slight fluctuation is there. So kindly do me a favor. So if you take a paper and blow the air below the paper, so paper will lift up, right? If you blow the air below the paper will lift up like this. But you do one thing. You give some curve to the paper and blow the air below it. I'm not blowing the air, sorry, blow the air above it. I'm not blowing the air below it. I'm blowing the air above it. So the paper should go down. But you know what? Some amazing thing will happen. So check, please. Check. My lips are above the paper, not below the paper. Check. The paper was lifting up. This is nothing but the principle of your airplanes. This is nothing but the principle of your airplanes. If you consider your airplane, so maybe this is an airplane, guys. Check. This is an airplane, okay? And the airplane is moving forward. But if the airplane is moving forward, then for the people who are sitting inside the plane, the air will be moving backward. Air is moving backward. So what will happen? Air will move around the plane. Now you do one thing. You consider the cross section of the wing. So this is the cross section of the wing. Okay. This is called airfoil cross section. I'm drawing this cross section separately. So I've drawn this cross section separately. Okay, maybe like this. So what is happening? Air is approaching the wing. Air is approaching the wing. And some air will flow above the wing. Some air will flow below the wing. It has been observed that the air above the wing, it becomes faster. And as per Bernoulli's principle, if this will become faster, the pressure here will decrease. So this will become a low pressure zone. This is going to be a low pressure zone. And air below the wing, it becomes slower. So as per Bernoulli's principle, this will become high pressure zone. So above the wing, there is low pressure. Below the wing, there is high pressure. So because of the pressure difference, there will be an upward force. This upward force is called as lift force, and it is responsible for taking the aeroplane up. Now, can you call this as Magnus effect? Can you call this as Magnus effect? No, we can't call it this as Magnus effect. Magnus effect means that if the forward moving body is spinning, here the forward moving body is not spinning. The wing is not spinning. If the forward moving body is spinning, then because of the spinning, high pressure and low pressure zone will be created and pressure difference force will come into picture. So this pressure difference, you call it Magnus effect only when the body is spinning. So you know what was proposed? It was proposed that when we are talking of aeroplane, when we are talking of aeroplane, why not make the wings as cylindrical bodies and give them a spin with help of motors? What did they say? They said that we will do one thing. We will make the aeroplane, we will make the wing of aeroplane as cylindrical bodies and we will give a spin to the cylindrical body. So check what they do. They will say the aeroplane is moving forward. This means the air is moving backward. Some air will move above the aeroplane. Some air will move below the aeroplane. Some air is moving above the wing. Some air is moving below the wing. With help of a motor, you give the spin to the aeroplane. A may be in this direction. You give the spin to the aeroplane. So at the upper surface, the surface of the wing and motion of air, they are in same direction. So they will promote each other. Friction will be less and this will become high velocity zone. So pressure here will be low. Bottom side, the air and the surface are moving in opposite direction. Check, the surface is moving in this direction, air is moving in backward direction. So they are going to oppose each other. Friction will be more. Fluid will slow down. So this will become a low velocity zone and pressure will become high. So at the bottom, pressure is high. At the top, the pressure is more. So there will be a lift force. So Magnus effect can create a lift force and make the aeroplane fly up in the sky. But the problem with this design is actually this design is better than airfoil design. In terms of lift force, Magnus effect gives more lift. But the problem is uh, cylinders are going to be solid. So they will be heavier than a conventional wing. So they will consume more fuel. And moreover, to spin them, additional motors will be required, which will make the aeroplane even more heavy. So even though the lift force is higher, but the fuel consumption will be more and ultimately the aeroplane will become slower. So aeroplane can go high in the sky, but it will move slowly. This is the disadvantage. This is the reason that we don't use these kind of wings. We don't use cylindrical shaped wings. Similarly, on the boats, there is a sail. Sail also operates in the same manner. Sail also operates in the airfoil manner. So the sail also generates a pressure difference. So on one side of the what you say sail, the pressure is high. On the other side, the pressure is low. Pressure difference will create a force, and the boat can change direction. So you can use this kind of sail also for changing the direction of boat. But again, the boat will become heavy. It will consume more fuel. It will slow down. So maneuvering the boat will become easy. Changing the sides of the boat will become easy, but it will slow down. So until and unless you have very light, high strength material, you can't use this design. But yes, this is a possible application of Magnus effect. Then there is a new kind of turbine. It's called as Darius turbine. If you will check out the blades of that turbine, the blades are vertical and cylindrical in shape. So that creates much more power than the conventional turbine. So as a homework, you can check out the Darius turbine. So check one beautiful application of physics in your daily ball games. Football. If you play baseball, baseball is not a Indian game, but in America it's played a lot. So the ballers over there, the throwers over there are known for their swings. So this is how you give a swing to the ball. I hope you learned something new. Okay. Since we are talking of some examples of Kerala. Let's see another example also. Let's have a look at another example also. You might have heard, you might have come to know about that movie. What movie is that? 2018. So it talks about the floods that have come in Kerala. Actually, Kerala is one of those Indian states which are most affected by the global climate changes. That's why from past 6, 7 years, lot of cyclones are coming towards Kerala. Earlier, the cyclones were not coming towards Kerala, but from nowadays, the cyclones have started coming to Kerala. And in fact, in 2021, there was a cyclone called as Cyclone Okchi. This is the photo of Cyclone Okchi. If you can check, the cyclone is quite big. It is covering the entire state and much bigger portion compared to Kerala. Now you might be thinking that why I'm talking about a cyclone in physics subject. Anyone? Does anyone have a doubt? Anyone who is watching the video, they can ask the doubt. Maybe Abhiraj or Rebecca, whosoever is watching the video, Sindhu and Murlidharan, all of you, you can ask doubt. Are? What did I say? Physics is the study of motion. Whatever is moving, whether it's a cricket ball, whether it's a car, whether it's a cyclone, whether it is the planets or it is the galaxy, or it is microorganisms in our blood. Whenever something is moving, that is physics only. So storm means air, air full of water vapors. So storms are nothing but physical bodies only. They are moving bodies only. We study them with help of physics. Now, here, I'm not telling you how the storm is formed because that you might have read in your books. So I know, especially in seventh class geography part. So winds, cyclones, this is a chapter, right? And I think in ninth class also some sort of chapter like this is there. So you consider it that geography, geology. But this portion of geography is actually physics only. I will tell you something different. Let me tell you something different. Just like in banana cake, I told you something different. Here also I will tell you something different, something special. You might not get this in your books. What happens is, say for example, you must be knowing centripetal forces. Centripetal forces. What you do, you take a rope, okay, and you take a rope, like this. I'll do one thing. I'll I'll take my hand up in the air. So this is one hand, this is other. I'm standing. I have a rope, and on the rope there is a ball, and I'm doing like this. I'm swinging the ball like this. Ultimately, what will happen? So ball will move on a circle. Ball is going to move on a circle. So you might be aware that when something is moving on a circle, you need centripetal force. This you must have heard of. So there is a ball which is moving on a circle. And to move it on the circle, we need a force which must be towards the center. This force is called as centripetal force. If this force is not there, the ball will not move on circle. If the force is too high, the ball will go like this. And if the force is too low, the ball will go like this. So it all depends on the centripetal force. What is centripetal force? If an object is moving on a circle, then there is a force towards the center. That force will be called as centripetal force. That force is responsible for maintaining the ball on a circle. Now, sir, in this example, what is the centripetal force? You have tied the ball with a rope and rope is stretched. So in the rope, there will be a tension. So rope is going to pull the ball like this. So when you are talking of tension in the rope, the tension will have two components. One is the inward component and one is the upward component. Upward component of the tension will balance the weight of the ball. And the inner component of tension will act as centripetal force and maintain the ball on circle. Okay. So we need some force which is towards the center. That force maintains the circular motion and then we call it as centripetal force. So we have to remember centripetal force is not some other kind of force. It is tension or gravitation. So in case of planetary bodies, the gravitation force is the centripetal force. Okay. Now, when we are talking of a cyclone, so what is a cyclone? So you say, sir, take a patch of water, take a surface of a sea near the equator. Near the equator, the sun is very bright. The sun rays are like vertical. Sun rays are very strong. So because of the heat of the sun, the air will become warm and the warm air will start rising up. Sir, not only the air will become warm, but a lot of water will evaporate also. So there will be vapors. So these vapors and warm air, they will rise up to the high altitudes. When the warm air will start moving, we will create a low pressure here. So outside there is high pressure, inside there is low pressure. So from high pressure to low pressure zone, the air will start coming in. By the way, I'm not explaining this. This so I'm just giving you a hint what you have read in books. I'm going to talk about something else. Okay. I will tell you which you do not know. Now, what will happen? So, outside there is high pressure, inside there is low pressure. So, air will start running in. And because of the rotation of the earth, this coming air will also start moving on circles. The air which will come in, that will also become hot and it will rise up. Now, the warm air with vapors which is rising up, so they will go to high altitudes, cold altitudes. And when they will go to cold altitudes, the water vapors will precipitate, giving you formation of clouds. So you can see this circular body of air, this massive circular body of air, which is having diameters of 1,000 kilometers. Now the thing is, now the thing is, this vertical entropy of air. Entropy means chaos. Entropy means chaos. This vertical entropy of air, how come the air particles are moving in circle? How come the air is moving in circle? There has to be some centripetal force. There has to be some centripetal force. Can anyone tell me what is the centripetal force? What is the centripetal force over here? What is the centripetal force over here? Very easy. Sir, very easy. Sir, high pressure, low pressure, na? Here also high pressure, low pressure. Sir, what happens is you do one thing, you see the cyclone from the top. Okay, you see the cyclone from the top. So actually what happens? So in the inner zone of cyclone, there is low pressure. And outer zone of cyclone, there is high pressure. So here high pressure means atmospheric pressure. High pressure means atmospheric pressure. And low pressure means less than atmospheric pressure. We call it as vacuum. Whenever the pressure is less than atmospheric pressure, we call it as vacuum. So outside the pressure is high, inside the pressure is low. So on the air which is revolving around like this, the air which is revolving around like this, there will be an inward force. This inward force due to pressure difference will act as centripetal force. And then the air will move in circle. So the high pressure outside, low pressure inside is resulting in pressure difference, is resulting in force. That force is centripetal force and air is moving in circle. Air is maintaining its motion in circle. So check where we started. We started with swinging of the ball. High pressure, low pressure. We started with swinging of the ball. High pressure, low pressure. We went on to the wing of an aeroplane. High pressure, low pressure. And now we are talking of a cyclone. High pressure, low pressure. So single concept is involved everywhere. And why it is physics? Because pressure is nothing but force. Now, one good thing I will tell you, which you might not find in your books. We will do one thing. We will look at the cyclone from the top. So when you look at the cyclone from the top, there is a center of the cyclone that is called the eye. Say, for example, in my presentation, there is a photo, right? Let me show you. This photo is there. So in the center of this cyclone, so I will highlight it. In the center of this cyclone, this center, A, this center of the cyclone is called as I. And what happens is the cyclone is divided into two portions. The inner portion is called as post vortex. Outer portion is called as pre-vortex. Okay, that I will tell you someday else. What is post-vortex? What is pre-vortex? That I will tell you someday else. Okay, but it happens. Inner portion of the cyclone, that is post-vortex. Outer portion of the cyclone, that is pre-vortex. And outside the cyclone, atmospheric air is at rest only. I saw it outside the cyclone, there is no motion. Outside the cyclone, there is no motion. Atmospheric air is at rest. Okay. Now, what happens is, if this is post vortex, this is post vortex, this is pre vortex, then at the junction of the two, so basically this circle, at this junction, the air speed is going to be maximum. At this junction, the air speed is going to be maximum. And you know what happens? If the eye of the cyclone is 0.1, outside the cyclone is 0.0, that is atmosphere, then pressure of atmosphere minus pressure of eye is equal to rho v square by 2, where v is the speed of air at this junction. Now you might be thinking, why I'm telling you this formula? It's first of all, this formula is very easy to find out. From your 11th class physics, you can find out this formula. Believe me, you can do it. But why I'm telling you this formula now? Because you might have heard of a device called as mercury barometer. What will mercury barometer do? Mercury barometer will measure atmospheric pressure. So what we have, we are in Kerala. I am sitting in Cochin. Okay, I am sitting in Cochin, and I have kept a mercury barometer over here. Right now, it's a sunny day. The air is at rest. So I will get the atmospheric pressure. I will get the pressure when the air is at rest. So I will get zero pressure, P0, P naught. I will get P naught. Now what happens? A storm comes. A storm comes. So when the storm will pass by, so when the storm will be up above the mercury barometer, so here you will have the eye. So you will get the pressure of the eye. Once you get the pressure 0, P naught, once you get the pressure I, what you can do? You can put the values in the two formulas, use the density of air, you can get the speed of air. This is how they tell you what is the speed of the cyclone. You might have heard in the news that a cyclone is approaching. Cyclone Ochki, Cyclone Titli, such kind of cyclones are approaching, and the wind speed in the cyclone is this much. Actually, they do not measure the wind speed. This is how they predict the wind speed. How do they predict the wind speed? By using this formula, by measuring the atmospheric pressure, pressure of atmospheric air at rest, and by measuring the pressure at the center of the cyclone. So this is how they use this formula. Okay. So check. Simple concepts. High pressure, low pressure, centripetal force, and what kind of big thing you are talking about. You are talking about Magnus effect, that is the swinging of the ball. You are talking about the storms. You are predicting the speed of air in the storms, and you are talking about the wings of the aeroplane. So when studied properly, these small things become big things, and then you are able to design big systems. So only thing is how you study it. Studying it properly is very important. I think I have taken a lot of your time, and I know you guys are hungry. But I'll do one thing. I'll show you one very basic, one very beautiful example. One more example. One last example. This we will wrap up quickly. So check out, please. This guy, you might not remember it like this. But when you will have a look at this photo, then you will definitely say he's Archimedes. He found out the buoyancy principle. What is buoyancy principle? You hold something in water, that object is light because the water will apply a buoyant force. Water will apply an upward buoyant force that will balance some weight. So some weight is balanced by buoyant force. That's why the object is lighter, isn't it? Now, principle of buoyancy, the same statement can be written in various ways. Like one way of writing it is, uh, guys, just hold on. I think uh, some problem happened. Anyways, no problem. Something has happened over here. Let me check. There was an important slide. Okay. By mistake, I have shifted it. No problem. But one thing is there that when we are talking of such massive ships, they are floating because of buoyancy, because buoyant force is balancing the weight. But a very small pebble is sinking because the weight of the pebble is not balanced by buoyant force on it. Here, the weight of the ship is balanced by buoyant force. That's why the ship is floating. Here, the weight of the pebble is not balanced by buoyant force on it. That's why it is sinking, right? So I think everyone knows it. Now, the same principle can be written in other way also. Say, for example, this is how we write it. A floating body displaces equal amount of water in kg. A floating body like a ship. So because of ship, for the ship, some portion is inside water. So if this is the main water body, then this much ship is inside water. So this much water is missing. We call it as displaced water. So say for example, there is a Costco ball. Costco ball is floating in water. Green cricket ball, green ball. It is floating in water. So this much water is missing. It is displaced water. So if Costco ball is 500 gram, this displaced water will be 500 gram. Only if the body is floating. There is a wooden block. It is 10 kg floating in water. Then the displaced water will be 10 kg. There is a boat which is 300 tons. It is floating in water. Then the displaced water will be 300 tons. And by the way, how much is a ton? I am 100 kg. So 10 people like me are a ton. So 300 ton will be 3000 people like me. Just remember this. 300 ton will be 3000 people like me. Now you will say, sir, everyone knows this buoyancy principle. What is new in it? Don't worry. We are talking about force. We are talking about physics. Have a look at this video. Have a look at this video. Just check what is happening. Just check what is happening. Check the bottom, a boat is inside. Check the top, there is a boat. Now, the gates will open and the boats will go outside. This is called as Falkirk wheel. It's in Scotland and there are two water bodies, one at lower elevation, one at higher elevation. I'll do one thing, I will switch the video off. Otherwise, you guys will keep on looking at the video. There is a water body at the lower elevation, water body at the higher elevation. So let me check. Yes, guys, I think there is some doubt. Beta Falkirk wheel. It is called as Falkirk wheel. Rebecca, beta, it's called Falkirk wheel. So one body is Bonnie and Clyde, I think. So it is a canal, Bonnie and Clyde. And the other canal is Union Canal. So say, for example, there is ground floor and there is top floor. How do you go? You take a lift. Similarly, one water body is lower, one water body is top. You take a boat lift. So that was a boat lift. That is actually a boat lift. Let me check if there is any photo over here. Okay, there was no photo. Okay, no problem. I'll show you the photo again. I'll show you the photo again. There is a boat lift. So Boat from the bottom can go up and boat from the top can come down. Now, you might think, why it is important. Beta FALKIRK. Why it is important? So just imagine there is an Activa, Honda Activa. That Activa scooter, if four people like me will sit on the Activa, it would be very difficult for Activa. Activa will slow down. And definitely, Activa cannot pull 20 people like me. So what did I say? 300-ton boat is 3,000 people. 300-ton boat is 3,000 people. You know what is happening over here? Here, with help of an Activa engine, we are lifting 300-ton boat. Here, with help of an Activa engine, we are moving 30 plus Fortuners by a distance of 32 meters within 8 minutes. Just imagine a single Honda Activa is moving 300-ton boat, that is like 30 Fortuner cars within 8 minutes. Isn't this amazing? Basic physics. Basic physics which you have learned in 9th class, that is applicable over here. The very statement which you wrote down here, this statement which you wrote down here is applicable over here. I know you guys might be thinking, how does it work? Don't worry. When I'm here, you don't need to worry. I will show you. Just hold on. I'll do one thing. I had kept it outside and I have made this kind of GIF also a few days back. So I will show you. It takes a bit of time. My laptop is actually slow. So it takes a bit of time. This is a seesaw, right? I hope you guys are able to see. You guys are able to see. You are sharing screen, right? Yes, you guys are able to see. So this is a seesaw. So two kids are sitting on the seesaw. Both are 50 kg. No problem. Seesaw is balanced. To move the seesaw up and down, it's very easy now. You just push one side, seesaw will go down. Or you just push up, seesaw will go up very easily. So when things are balanced, moving is easy. Now you do one thing. One person is 50 kg, other person is 70 kg. Seesaw will be unbalanced. It will fall down. Similarly, there is no student on the other side, but on one side, there is 50 kg. Seesaw can, so this is unbalanced. Now to move like this, you need a lot of force because seesaw is unbalanced. Similarly, Falkirk wheel is like a seesaw. So on the left hand side, there is a seat where you have a boat. On the right hand side, there is a seat where you have a boat. So this is also a seesaw. So I'll do one thing, I'll show the seesaw. So there is a water body at lower elevation, water body at higher elevation. In between them, there is a seesaw. And the seesaw has two seats. It has two carts. The carts are called as caissons. Let's focus on one cart. So this cart will be called as caisson. It's made of high grade steel. Maybe it's 300 tons. And since inside the caisson, the boat will sit. So we have some water also so that the boat can float. So this water is 200 tons. Okay. So how much is total? 200 water plus 300 caisson. So that is 500 tons. So on one side of seesaw, there is 500 ton. On the other side of seesaw, 500 ton. Seesaw is balanced. Now let's do one thing. Let's bring the boats. So what we have a 50-ton boat at the bottom, which wants to go up. A 100-ton boat at the top, which wants to come down. Maybe there is no boat at the top, only the bottom boat wants to go up. Or there is no boat at the bottom, only the top boat wants to come down. Any possibility can be there. Maybe the two boats are same in weight. Maybe the two boats are different in weight. Let's see what will happen. So we will have gates. We can open the gates. Through the gates, the boats will come inside. We will close the gate. Now check. Is the seesaw balanced? You have 100-ton boat on one side, 50-ton boat on other side. Is the boat balanced? No, sir. The boat is not balanced. This is what you guys are going to say. Actually, the boat is balanced. Let's check. Actually, the seesaw is balanced. Seesaw is balanced. Let's check. So check please. This is one caisson, 300 ton. In the caisson, there was 200 ton water. The boat is 100 ton, which has to come inside through the gate. But one thing you remember, the boat is displacing water, which is 100 ton. Now this boat will come inside. Basically, a floating body displaces same amount of water. Right? Floating body displaces same amount of water. That is 100 ton water. Now what you will do, the gate is open, the boat will come inside. But once the boat will come inside, it will displace water and the gate is still open. So this displaced water, where will it go? It will go outside only. So when the boat is coming inside, it is displacing 100 ton water. That 100 ton water will go outside. So initial water was 200 ton, but when the boat came inside, 100 ton water went outside. So now what will happen? So check please. Out of 200 ton water, 100 ton water went outside. So only 100 is left. So in the Kaizen, now you have 100 ton water. Now you will close the gate and now you check the weight. So 100 ton of boat, 100 ton of water and 300 ton of Kaizen. That is total 500. Similarly, on the other side, 50 ton boat came inside. So 50 ton water went outside. So the Kaizen is 300, 200 water minus 50 going out, 150 plus 50 ton boat. That will again be 500. So whatever boat is there, whether boat is there or not, doesn't matter. There will be 500 ton on the left hand side, 500 ton on the right hand side. So seesaw will always be balanced. And to move the balanced seesaw, it's very easy. That's why this lift will move 3,000 people like me just by an Activa Intel. This is the marvel of this system. From a very simple statement that you learn in ninth class, you were able to design this structure. Isn't that amazing? So these things that you learn, that is science. But when you use science to make something like this, that becomes engineering. So engineering is part of science only. And you guys are majorly learning science to become engineers. Actually, nowadays, there is not much difference between engineers and scientists. They are kind of same only. So I think we have discussed a lot of examples. But frankly speaking, I had some other examples also. But I will not take too much of your time and just show you a glimpse of examples which I thought I will show you. But today we will wrap up, okay? So these were some discussions that I was going to have with you. Not these one, these are just examples where buoyancy principle is applicable. And yes, I had thought I will tell you that how they detect planets. So this discussion we will do someday else. And I had also thought I will tell you that in every house there is a roly-poly toy. So how this 50 rupees or 100 rupees toy and something which is 20,000 crore, their design is similar. I had thought of telling you this, but yes, I have taken a lot of your time. So I think it would be better to wrap it up. But guys, one thing I would like to say that check out these four words. From few days, I have been visiting a lot of schools and I've been telling this to all of them. Check out these four words. All these words, they are written in different languages. So Chinese, Punjabi, Arabic, Japanese. But the thing is, these are all same word. One. It's one only. And in Malayali, you call it like this. A Malayali guy will not know Chinese and a Chinese guy will not know Malayali. But everyone will know this. It's because maths is the most simple language. Everyone understands maths. Definitely, it's the most simple language. Same is the same thing with science also. Science is, believe me, the most easiest subject of all. Then why do we fear it? Because we don't learn it in a proper manner. Those students who are in 9th class, 10th class, 11th class, 12th class, you know what will happen? I will ask them 36 plus 25. So 6 plus 5 is 11. Why do we take a carry forward? 36 multiplied by 25. So 5 into 36, that is 180. I will write 180 and then I will put a cross. Why do we put a cross in the second step? But these basic questions also, if we ask the students, they are not able to answer. Why? Because we are just interested in knowing the method. We are not interested in why we are using the method. You don't go behind the fundamentals. You just want the method. You don't go behind the fundamentals of the method. That's why you think that science is difficult or maths is difficult. But if you will study it properly, sir, how to study physics? So very easy. Whenever you start a topic, read the definition of the topic. Check out the history of the topic. How Archimedes discovered buoyancy? What are the various applications of buoyancy? Buoyancy is not only responsible for making your ship float. Buoyancy is responsible for Falkirk wheel. Buoyancy is responsible for convection current. Buoyancy is responsible for climate and weather pattern. This means the clothes I wear, the food I eat, that is because of buoyancy. Because of buoyancy, all the deserts lie in the same latitude. Because of buoyancy only, the sun is hot at its surface. So all these examples are because of buoyancy. So a small topic has so many applications. So check out the applications. In this way, you will get interested in the subject. Once you develop interest in a subject, you start liking it, you will focus on it. Your performance will definitely improve. Now, while checking out the formula, see what kind of formula it is. How do we derive that formula? Sir, we are finding out force. This means we will apply Newton's law. Sir, we are finding out energy. How much power is produced by turbine? That is energy. How much power is consumed against friction? That is energy. We will apply energy conservation principle. So what is the method of finding the formula? Why we are using that method? In the method, what are the assumptions? What will happen if I change the assumption? What is the meaning of each equation? How the equation looks in real life? Where the equation looks in real life? What is the meaning of each and every term? Then find out the formula, solve the basic question. Through basic questions, you will understand how to fetch the data. Then go for competition level questions, because ultimately you have to clear competition. Just by school, you cannot make a good career. After school, see, this is the reality of current education system. Without cracking good competitive exams, we can't make our career best, right? So go for competitive exam questions also. Try to learn. I have found out one answer in the question. Can I find out something else also? What will happen if I change the statement of the question? What will happen? Can I relate this question to other subjects? So do like this and revise a lot. Believe me, with the 5-time revision, 6-time revision, not only your speed will increase, accuracy will increase, but you will get the detail of the topic and you will also get shortcuts. This I will tell you next time why it happens. So as you saw my intro video, I'm Pranshu Mahajan. I'm currently working as HOD for Physics and Engineering Department of Vedic E-Schools. And we are bringing up a lot of amazing faculties for you. And we are going to launch IIT JEE and NEET coaching for you guys. And this is the way that we are going to teach. That say, for example, when you are solving a differential equation, this is the basic method of solving it. But why not solve it without paper and pen? The differential equation says you take the derivative of y 2 times, you get y again. This is only possible in exponential function. So there is no need of solving the equation. 11th class students, they check out matrix multiplication. This is the method of matrix multiplication. But you know what? For these two matrices, you can find out the answer directly also without multiplication. This is how we are going to teach you. We are going to develop your concepts, the fundamentals, your logic, your imagination skills, which is not only going to help you in your competitive exams, but even in your future life, even during your graduation, even during your careers. So guys, I hope you enjoyed the session and I'll see you next time. If you guys like the session, It would be amazing if you can share it with your friends. That would be really helpful for us. And if you have any kind of doubts, you can reach out to us. If you have technical doubts, you can put your comments in the put your questions in the comment section also. I will definitely check it out. It was amazing to interact with you. I'm very happy. I'm very obliged that you learned something new today. And I will keep on bringing new sessions like this. Thank you guys. See you next time. Bye bye.